I put them together. Okay, how they get this equation is not important. Okay, but okay, you need to know about this. Okay, and you need to know about the simplified form. Okay, but I mentioned in your syllabus. Okay, don't just memorize oxidized form only. You remember oxidized form divide by reduced form also. Okay, you divide. Okay, why they have removed it in your textbook? Okay, because they are referring to only this example, which is correct. Okay, which is correct, which is going to be copper 2 plus 2 electron to give you copper. Copper is metal, yeah, so we do not need to write the reduced form. Okay, no need to write. Okay, but in your syllabus, okay, they have mentioned specifically examples that may include this, okay, which is similar to the one that mentioned in the textbook, but the one that is missed by the textbook is this one. They can also ask you based on this. It means that, okay, your simplified version of the formula cannot be applied for all the questions that they will be asking in your actual paper. Okay, which is going to be, it must be oxidized species, which is going to be on the left, and this is going to be the reduced species that's supposed to be on the right. So therefore, okay, I will suggest, okay, you can use this, okay, but okay, remember oxidized form divide by reduced form. You ignore, okay, when this is involving metal and metal ion. You ignore the reduced form. Okay, but if you have ion and ion, for example, like this, okay, ion and ion, okay, you need to include this one, reduced form. Okay, do remember this is a simplified version which is required in your, okay, in your syllabus. Okay, they didn't even mention about the original formula. Okay, but do remember, okay, the original formula will come into place. I don't know whether they will ask you in exam. Okay, questions like this. I think I made an error term over there. Okay, I think this one I took it from the textbook and then the answer from the textbook, but they did something wrong over here also. Yeah, I discussed this with you, okay, during yesterday's lecture. Okay, but I didn't discuss about this. Okay, if you look into this, okay, you can see it is done at 0 degrees Celsius, and I mentioned to you, you can only use this formula, okay, under the condition where the temperature is 298 Kelvin. If the condition is not 298 Kelvin, then you have to use this formula. But that formula is not even mentioned in the syllabus. So I do not know whether they are going to ask similar question like this in your exam. Okay. But what you need to know, yeah, this is another thing that we will go extending the syllabus, okay, which is going to be, we learn about the full formula. Okay, you need to apply the full formula. So when they apply this formula over here, the working is wrong. You cannot use the simplified formula for this. Why? 0 degrees Celsius. Then how do I apply using the correct formula? E equals to E standard plus RT ZF ln, okay, ln, and then oxidized form, I just put OF, and then reduced form, okay, I put like this, RF. Okay, or if you don't know, this is left, this is going to be right. Yeah, so here if I put in the E value, okay, 0.8 plus R is going to be 8.314. You check at your data booklet. Okay, we will follow the value in data booklet. If it is 8.314, we use 8.314. If it is going to be 8.31, then we use 8.31. Okay, so the temperature is going to be, now you have to change. Don't go and put 0 over there, yeah, guys. Yeah, don't go and put 0 over there. I think it's quite sometimes we will be rushing and then we put the 0, and then what happens if you put 0? 0 times R, 0 times anything is 0, okay, and then the ln you times is 0, then you will say the E value is E standard, then end up giving the answer as 0.8. No, it's wrong. Okay, what is the mistake over here? 0 degrees is going to be 273 Kelvin. We want it in Kelvin. Okay, so you put 273, okay, divided by Z is going to be, this is silver ion, so Ag plus electron to give me Ag, so 1, okay, 1 mole of electron. So it's going to be 1 Faraday is going to be 96500. You can get it from your data booklet, okay, and then this is, do remember, is Ln, not log. Okay, if you use the simplified form, then it's going to be log. They already changed into log. Now this is Ln, okay. You need to use a natural log, okay, and then the left divide by right. So left Ag plus is going to be 0.0002, and then silver is constant, so no need. So you just put over there. You can remove this part, and then you find out. Okay, if you calculate, okay, the funny thing is, I think you will get something similar to 0.580, so which is 0.6 something. Okay, you can just go and find out. Okay, you will find out that this is going to be similar to this value, okay, positive value. So what is important over here is, okay, I think the working is wrong. Okay, don't use the simplified formula. Okay, like what is shown over here. Okay, you need to use the full formula if it is going to be non-298 Kelvin. Okay, you need to use the full formula, even though the full formula is not mentioned in your syllabus. Okay, the syllabus actually mentioned about this. Okay, but again, they say for example only. Yeah, so Nernst equation. This is also Nernst equation. Okay, so they will actually, I think Cambridge will come with way to justify. Let's say they ask this question, they say they will tell them you should know, yeah, under different temperature, how do we apply Nernst formula? So why we get this? Okay, we get this from here. So they can actually put back to us, okay, that we need to know about the original formula or something. Yeah, so we need to learn everything. Okay, let's learn everything. Okay, if let's say they ask us about related questions related to non-298 Kelvin, be ready to use the original formula. Yeah, original formula. What's the difference with the original formula? The original formula has the RT, okay, divided by ZF, okay, and then it is going to be natural log. Okay, but most of the time you can always use this, okay, formula 0.059 divided by Z log 10. Okay, you can use that. Okay, so this one, okay, I'll leave it to you, because that's why I asked you, yeah, when we try to summarize, okay, what we have learned for the calculation, you do not need to memorize a lot about the Faraday constant, because I think by this time you should know. Yeah, Faraday, I just look at the number of moles, then I relate, I can calculate Q equals to IT, I can calculate, no problem. But memorizing the formula, yeah. So like, for example, this will be one of the situation in chemistry where you memorize formula. Okay, another time I think maybe under carbonyl compound, okay, that I told you that you need to memorize 2,4-DNPH. How does it look? There are certain situations, okay, in chemistry where you need to memorize. Yeah, that one we cannot help it. Yeah, as much as I do not like students to memorize, okay, there is no other option. Yeah, they will not. I even check whether they have this in the data booklet. It's not there. Okay, so you need to know. Yeah, the formula is not mentioned in the data booklet. You must memorize. And another formula that is not inside the textbook is this one. So today we will learn about this as well. Yeah. So that's why I'm taking time. But again, it's 15 minutes. Okay, left. Okay. So anyway, you can see the next checkpoint. Okay, you see here 298. No need to worry about the original value, but you just need to apply. Okay, so you apply the formula. E value is 0.34. Okay, this one, how do I get this? Okay, you write Cu2 plus, okay, plus 2 electron to give me copper. So we are talking about 2. Okay, this is going to be 2. And then the oxidized form, why there is no reduced form? Okay, you check. Okay, this is going to be metal, won't have any reduced form. So oxidized form, what is oxidized form? Left. Okay, this is left. So this is going to be concentration 0.001. So you put 0.001, and then it's log, because simplified log 10. Yeah, so if you use this, okay, when you calculate the E value, you will get 0.25, which is similar to our prediction. What is our prediction? Okay, if I want to apply my prediction over here, my prediction is Cu2 plus is less than 1. Okay, if this is less than 1, then I know that the position of the equilibrium will be shifted to the left to increase the copper 2 plus. If my value E standard is 0.34, if it is going to the left, it will become slightly more negative than 0.34, maybe less than 0.34. So that's why when I calculate, you can see that you get 0.25, which is your prediction is also valid. Okay, and do remember, when I compare the prediction in this case, I'm not comparing with the 0.3, it's just prediction for one cell. Okay, you're not predicting between two cells. Okay, not yet, it's only one half cell. Okay, so the prediction is still going to be correct. You can still predict, yeah, but you don't have the numerical value. Okay, so the one that if you're confused, the difference between 0.3 volt and so on, that will come when you have two half cells connected. Okay, that is the part. Okay, when I say that the prediction will be valid and the prediction is not valid. Yeah, so predicting feasibility. So if you look at it, yeah, okay, it might be confusing, you know, feasibility. But again, we have learned about feasibility, okay, or whether the reaction can happen or not. Yeah, feasibility, a spontaneous reaction, whether the reaction is spontaneous or not. You remember, feasibility doesn't mean the reaction is happening. It is happening spontaneously, but do remember, a feasible reaction is not something that is fast. It's not something that is vigorous. Okay, do remember. So the reaction can happen, but it may require catalyst. It may require certain condition so that they can happen properly. Yeah, so certain things applies. Okay, but we have learned under entropy. Okay, if you want to predict feasibility, your Gibbs free energy must be negative. Okay, you learn about that. And then we have different conditions and so on, depending on the temperature and so on. Yeah. So Gibbs free energy, if you remember this, Mr. Gopi is not so hot. Okay, so it means, okay, delta H, okay, minus, okay, delta, sorry, Mr. Gopi is not so, I also forgot that. So hot T, I think, you see, this is also helping me to memorize stuff. Yeah. So here you can see my enthalpy minus the T, and then entropy, change in entropy. And do remember, okay, in order for the reaction to be feasible, okay, my Gibbs free energy must be always negative. And okay, remember the quadrant. Okay, if you remember the quadrant, if they are, okay, if they are different, easier to predict. If you don't remember, it's okay, I'll just recall a bit. If it is going to be different, easier to predict. Okay, so if it is going to be spontaneous, when it is going to be spontaneous, when your enthalpy is going to be negative, and when your, okay, when your S is going to be positive. Okay, when they are moving randomly, and then exothermic, then spontaneous. It's going to be non-spontaneous, okay, when it's going to be delta H is going to be positive, delta S is going to be negative, non-spontaneous. Okay, and then remember the part for same signs is going to be difficult to determine. So let's say I just put this one positive, positive, delta H, delta S is going to be negative and negative. But now this is much more easier. Positive, positive, it's only spontaneous when the temperature is positive. Think positive. I hope you remember this. This is going to be spontaneous if negative and negative only when the thing negative temperature is lower. Okay, so all this, okay, I have taught you. Yeah, I taught you. So it has relationship, okay, with the enthalpy. Okay, it has the relationship with the entropy. Okay, it has relationship with the temperature. So whatever it is, if you have okay, E value. Then they must be related also feasibility. So there is a formula that can relate the E value and Gibbs free energy. The formula is, don't forget about this, E. Sorry, not E, negative. Okay, Gibbs free energy, okay, is going to be negative NFE. Okay, what is N? N is the number of moles of electrons that is involved. F is the Faraday constant, 96500. Okay, E is the E cell, okay, the standard E cell. And then, okay, what else? I think that's all, yeah. What is important is, that's why I put this as important. Gibbs free energy, okay, if you use this formula, okay, NFE, you must make sure that your Gibbs free energy is joule. Okay, always remember. Normally it will be joule, okay, but joule per mole, yeah. Normally it will be like that, but some of us, because the number is big, okay, we have tendency to change it into kilojoule. So you need to make sure it is in joule. Okay, why? Even when we use the formula, this formula also, we need to be very sure, because why? Enthalpy change, the H is can be, most of the time they are written in kilojoule. You must change it into joule. So because your entropy is always in joule in your syllabus, yeah. So again, this one, to make it easier, change whenever you are applying any formula, okay, change it into joule. Okay, this is going to be a simple rule, yeah, change it into joule. Okay, so let's learn about how to apply. Yeah, this one, okay, it is very important, because, okay, if you look at the syllabus, okay, in the past, okay, for this electrochemistry, we only learn until 8 and 9. There is no point number 10. Point number 10 is only the new addition for your syllabus. Okay, it means your seniors, and if you look at the past papers, there won't be any questions related to this. Why? Because this is, you are the first batch that is going to learn about this. And some teachers, okay, they might miss out teaching this also. Okay, and they will not even realize after 2 years. Okay, do remember, this is a new addition, okay, and it is being added, okay, in the new syllabus. And if you are using the textbook, yeah, the new textbook, it is found under entropy. In the old textbook, it's not there. Okay, it's not there. So here, okay, I have taken certain parts from the textbook and put it over there. Even the examples are from the textbook, but it's not sufficient. Okay, it's not sufficient, and I will tell you why. Okay, because when we learn, okay, we need to learn, okay, and be prepared for every single thing. But for the textbook publishers, for them, this is something new. I will actually update next year. I will update the following year. Yeah, they can get away from it. Okay, but during exam, okay, when they ask and you don't know the answer, can you get away with it? The answer is no. That's why we need to always explore further. Okay, so here, how to apply, okay, the formula you see here, Gibbs free energy is negative NFE. Okay, so calculate, they are asking you to calculate the free energy change, okay, for the magnesium with zinc ion, and state whether the reaction is feasible. Yeah, so here, okay, what I need to do, you find out the E cell between these two. Whatever that we learn, we apply. Okay, so negative, negative. Okay, this is more positive. So this one will go to the right. This one will go to the left. Okay, so when that is going to go to the right, okay, I will rewrite this, zinc plus 2 electron to give me zinc, then negative 0.76. This one is magnesium. They will give me Mg2 plus 2 electron, and then this is going to become positive 2.38. Okay, so when I add these two together, okay, what I will get, okay, is going to be, okay, let me take my calculator, okay, 2.38 minus 0.76. Okay, I will get 1.62, positive 1.62. This is my E value. I calculate the E cell. Okay, once I calculate the E cell, now you look at the electron. Okay, how do we look at the electron? You see the electron, when two electron will cancel. So I will get this equation. When I add, I will get this equation. Let's not waste time, okay, to rewrite this. So I know that the number of moles of electrons that is involved in this particular equation is 2 electrons, 2 moles. Okay, so when I apply, it's negative. This is 2. F is 96500. The E value is 1.62. Okay, and you can see if you use that, you will get negative 313, and then it's supposed to be in joule. Okay, but here in the answer, they have simplified to kilojoule. Okay, but anyway, okay, if you calculate, you will get this. Okay, because this is negative, can I predict whether this is feasible or not? The answer is feasible. Why? Gibbs free energy is negative. Okay, now, so this is going to tell us what, even in simple way, yeah, I'll tell you how to actually even predict in a simple way. Gibbs free energy must be always negative. As long as your E value is positive, right? As long as your E value is positive, this value is positive, this value is positive. So negative times positive is negative. So Gibbs will be negative. So as long as E value is positive, yes, Gibbs free energy is going to be negative. So this is going to be another rule that you can remember. Yeah. As long the E value is feasible, that's why if you refer to here, E standard is positive, Gibbs free energy is negative, yes, they are feasible. Okay, and then we have that formula. Unless they ask you to calculate the Gibbs free energy. In this case, they ask you to calculate. But if they ask you to predict, enough, just by looking at this is enough to say whether they are feasible or not. But now they are asking you to calculate. Then only you use the formula if they ask you to calculate. Yeah. So the next, okay, here is going to be another example. Okay, similar way. Okay, similar way. They ask you to calculate. Okay, so if I combine them, so you see negative 0.14, negative 0.13. Okay, this is more positive. So this will go here. Okay, so if I try to reduce my work, yeah, negative 0.13. So this one will go the other way around. So this one is going to be positive 0.14. Okay, what I will get positive 0.01. It's positive. So if I want to predict without calculating, yeah, it's feasible. I think everyone should know E value is positive, then it's going to be feasible. Okay, but I want to calculate. If you want to calculate, Gibbs free energy equals to negative NFE. So negative N. What do I use? 2 electron, because left and right, they will cancel. So 2 times 96500. Okay, then you times with 0.01. Okay, and then you will get a value. Okay, this one I don't have the answer, but you can calculate. Okay, you can calculate and you will get a negative value. So whether this is going to be spontaneous or not, whether it's feasible or not, it's going to be yes. Then you can calculate. It will be a negative value. Yeah, but okay, this is going to be extra. You cannot even find from the textbook. You cannot find it anywhere from your past year paper. What if? Yeah, what if? Okay, like I sound like Marvel what if series. Yeah, what if? Okay, they ask you, okay, about this kind of question. What is different about this? I'll show you what is the different part over here. It is going to be aluminium. Okay, 3 plus, okay, plus 3 electrons supposed to give me aluminium. I just need to look at this, okay, and then I'll just write down the standard reduction formulas, yeah, a standard reduction half equations. Okay, Cu2 plus, okay, plus 2 electrons, then it's going to give me copper. I get this, okay, then what I need to do, okay, I need to find out what is the E value. I have all these values, aluminium and copper. Let's see. For aluminium and copper. Aluminium. Aluminium, negative 1.66. Okay, someone help me to memorize. Okay, negative 1.66. Copper, okay, copper is going to be, I think we can just like, okay, we just bring it here. Just paste it here. So if you look at aluminium, it's negative 1.66. Yeah, I'll just write down negative 1.66. Copper copper is going to be 2 plus, yeah. So this one, select the proper one, yeah. Copper 2 plus 2 electron, 0.34. Okay, 0.34. So now, okay, I know, okay, that one that is more positive, this one will go to the right. So this is going to be 0.34. This one will go to the left, okay, which is going to be positive 1.66. Okay, but just to avoid confusion, I will rewrite. Okay, copper, okay, copper 2 plus 2 electron to give me copper is going to be 0.34. Okay, aluminium is going to give me aluminium 3 plus 3 electron, which is going to be positive 1.66. Okay, if I want to find the E cell, yeah, correct, you just straight away add. Yeah, when you add, you will get 1.66. Okay, you add with 0.34. Okay, so 2. Yeah, 2. So E value is 2. Okay, positive 2. And then here, I just want you to do something. When I write the equation over here, A per even, okay, I need to eliminate the electron. What should I do per even?
Just minus.
Cannot. This one, yeah, just you combine, it's okay, but you cannot just simply, the answer is not minus, it's just add both of them. But can I simply add both of them? You see here and here, they are not the same. So what I do before I write?
Balance it.
Balance it. How? Okay, you times this by 3, right? Make it 6. You times this by 2. Make it 6. Okay, it means that everything times by 3. Okay, everything times by 2. Okay, and you will get 6 electrons on the left, 6 electron on the right. When you add these two, then you will eliminate the electron. Okay, does it actually, do we need to times 3 over here, times 2 over here? The answer is no, no need. Okay, we don't do that. Okay, for the electrochemistry, we no need to do that. Okay, so when you do that, okay, what happened? Then only we are going to get 3 copper 2 plus, okay, plus 2 Al, okay, to give me 3 Cu plus 2 Al3 plus, okay, and then you'll get this. Okay, where am I going with this? You see, this one is this. Okay, where am I going with this? I'm just going with, okay, the number Gibbs free energy equals to negative NFE. What is this? I need to find out. The number of N is no longer, because you have 2 and 3. So what is the N? The N is, okay, because you times by 3, because you times by 2, how many moles of electron involved in this, Jackson? Jackson, how many moles of electrons involved in this particular equation?
6.
Yes, the answer is 6. Okay, the N, okay, you need to be very careful because earlier in all the examples in the one that is given in the new textbook is all where the electron is the same. Electron is the same. They have given another 3 more examples in the new textbook, okay, but all the electrons are the same. But the moment where they give you situation where they have different number of electrons, such as like this and this, the additional step that you need to do is this one. Okay, you must find out what is the common multiple. Yeah, so which is going to be 6. Okay, 6. So this is 6. So when I apply negative 6 times 96500, and then the E value is 2, because this one I can find out already. This is positive. Okay, positive, so feasible. Yeah, feasible. But if you want to calculate the Gibbs free energy, you can calculate. Okay, you will get a negative value and you will get the answer. Okay, because it's negative, yeah, the answer it is feasible. Okay, it is feasible. So